The arrival of quantum computers could be more historic than previous technological revolutions. We're standing at the dawn of a transformation that could redefine everything we know about science, intelligence, and even reality itself. But a dark cloud has recently passed over this hopeful future. One of the world's most advanced quantum computing systems, hailed as a breakthrough, was suddenly deactivated due to an emergency that shocked the global scientific community. In a rare and gripping interview, theoretical physicist Michio Kaku revealed disturbing insights about quantum technology. He also hinted at something far more astonishing: connections between quantum consciousness and extraterrestrial intelligence. The implications of his words continue to ripple across scientific and philosophical circles. Why was this powerful quantum machine shut down? And what revelations has Kaku brought into the light? Quantum computing isn't just the next step, it's a giant leap. For decades, classical computers have served us well, but they're limited. Quantum machines, operating on principles like superposition and entanglement, can process data in ways no digital computer ever could. Where traditional bits are locked into zeros and ones, qubits can exist in multiple states at once, unlocking the potential to solve problems that are practically unsolvable today. This all began with the birth of quantum theory in the early 20th century. Then in 1980, Paul Benioff imagined a computer that worked using quantum mechanics. Richard Feynman followed, suggesting that only quantum computers could truly simulate nature at its deepest level. These ideas sounded like science fiction, until they weren't. In 1994, Peter Shor developed a quantum algorithm that could, in theory, crack the most secure encryption. Suddenly, the world realized just how powerful quantum computing could be. Over the years, researchers like Isaac Chuang built primitive quantum devices, and in 2001, IBM used magnetic resonance to control qubits for the first time. The age of quantum hardware had begun. In 2010, Chinese scientists made headlines by achieving quantum teleportation, a huge leap toward creating secure quantum communication networks. Then came the D-Wave system, developed in collaboration with NASA and Google. Early results were astounding. D-Wave 2 solved complex optimization problems at speeds up to 10,000 times faster than traditional systems. But then, the dream stalled. Amid growing concerns over national security, encryption risks, and artificial consciousness, the government ordered the shutdown of D-Wave systems. The fear? That such immense power could be misused, or worse, misunderstood. Still, the march of progress didn't stop. In 2019, Google announced quantum supremacy. Their processor, Sycamore, solved a specific problem in seconds that would have taken the best supercomputers thousands of years. The scientific world was shaken. By 2020, IBM followed with its commercial quantum platform, IBM Q. This marked a turning point. Quantum computing was no longer confined to labs. It was now accessible to companies, researchers, and even universities. For the first time, the quantum world was open for business. But with this access comes responsibility. Quantum computers could one day crack every password, simulate black holes, and even decode the nature of consciousness itself. Some scientists, including Kaku, suggest that quantum systems could one day interact with alien intelligence. With their ability to calculate vast probabilities and simulate unknown conditions, these machines might finally help us solve the Fermi paradox, the mystery of why we haven't yet encountered extraterrestrial life, despite the overwhelming odds in favor of it. This theory now has sharper teeth. If intelligent life is out there, perhaps it's operating on a level of physics we've only just begun to grasp. Quantum computing might be the bridge between our world and theirs. It could even help us understand the nature of reality itself, suggesting that consciousness, space-time, and energy are far more interconnected than we ever imagined. But it's not just about aliens or science fiction. Quantum computing could rewrite physics, medicine, climate science, and AI. Its implications ripple through every field, from unlocking new dimensions of the universe to building simulations that model entire galaxies. Or, perhaps, entire timelines. As we stand on this edge, the shutdown of powerful quantum systems reminds us. We are opening doors to realms we may not yet be prepared to enter. The technology is no longer just an idea, it's real, it's here, and it's evolving fast. Every qubit added, every new algorithm tested, brings us closer to understanding our universe's most elusive truths. And perhaps, one day, we'll look back at this moment as the beginning, not just of a new era in technology, but of a new era in our place in the cosmos.